Ladies and gentlemen, welcome to ENCE411 water class. In order to separate our contaminants out from the Brita filter media, we performed an acid digestion according to EPA standard method 200.7. First, we moved the filter material into separate jars and took the overall mass of each sample. Next, we dried the sample to a constant weight at 45 degrees Celsius in order to dry out the sample for 1 day.
We weighed out approximately 2 grams of filter material and placed them into 250 milliliter flasks. Then we added 4 milliliters of nitric acid solution and 10 milliliters of hydrochloric acid solution. The acid is used to help oxidize inorganic material and nonmetals in order to separate them into ions and separate them from our filter material.
The next step was to reflux the samples for approximately 30 minutes after boiling. Our samples took a very long time to heat up because we did not set our hot plates up to a high enough temperature. However, once they finally started to boil, we started our time. After the samples cooled, they were transferred to a 100 milliliter volumetric flask and diluted up to volume with distilled water. Next, the samples went into the centrifuge, and then once they were clear, they were sent to the ICP for testing.
Our Brita filter samples were found to capture copper, zinc, sulfate, and high levels of iron. The amounts of each of these metals captured generally decreased with more refills. Based on class tap water data, the Brita filters were effective in removing a significant percentage of copper and zinc from the water, but removed very little sulfur. The levels of arsenic, cadmium, and lead in both the Brita filter samples and the tap water samples were negligible.
Material.
This?
No, like laying down all the way.
What?